Good morning, good morning. Starting here. Just trying to finish the exercise before work. So let's continue. So write the function calculate smooth word probabilities, which is this one, which basically is this. By the way, for everyone, maybe I'll put it on the thing. I'll stream tomorrow more. I'll put it tomorrow on the schedule. But yeah, I'll stream more tomorrow from 4 or 5 hours from now, and I'll stream for a longer time so we can get way more done. So we have this function. So counts, maybe let's put here. Counts is a matrix. Document classes is a list with class label integer value label int and text or document, I guess document. Maybe per document. Let's see. An alpha and a smoothing parameter. Smoothing parameter. Alpha, we just put alpha as a smoothing parameter. Smoothing param. Until the smooth as a matrix, the result should be the values. It looks so ugly. Where indicates how often the word appears in all document. Okay. How often the word D appears in all documents of the class C. Okay. Specifically, the input counts has one row for each document and one column for each word in the vocabulary. So basically like this. Yes. So basically the count is like this. Where's the we lost that? I'm calling it. So with this, yeah. Counts has this. So counts. Maybe we put it here, and it counts. It's a matrix where like the columns, these are the words, and then okay, I would have to draw it. Okay, this is too much for drawing, but yeah, the column, maybe I just tap it a bit. Column, you got the words, and the row is the row each document. So basically it's like this, telling like these are the words, these are documents, and then this is the whole words, and then if it shows up do I have like count vectors, small data, text, small data? Did it go transform at some point? Nope. Ah yeah, count vectorizer, small count, small data. We transform it anyway, so let's keep going. One row for each class C and one column for each word WI. Counts at, do word apply the function for testing to small. Okay, so we need to calculate that thing, which, how do we name it? Total word count per word. I'll count per word. Can name it like that. Yeah, there's specified tokens. Using if has attributes count to rate count. Work on both types. Okay. And then this is the sum of total of all of it, yeah, of all the count, total words per count per word. So it would be basically iterating. Basically, we put here iterate over each row. We have the same, we need to have like the same list, but then it will be only one dimensional, which would give us the count. Total count per word, it will be like something like this. It will look like 1, 3, 4, whatever, something like this, which then the words would be the, I don't know, 2, like, walk, stay, something like that. And I said like 2 appeared once, like appeared 4 times. So that's basically the thing. And then we will, the sum here will be summing out all of this. I'm not sure if this probably gets included into the sum, but okay, we will do that later. So we iterate over each row. We create this. We create a list with the length of the row. It has to be the same because that's basically the vocabulary. And then for the same index, just add like the total count per word. Then we get the index más igual the whatever we are iterating, the count ji. This, I have to see, this is row and column, or is this column and row? Maybe like this. Let's see, I'm not sure which one is the column, which one is the row in the order. So if this is the matrix, Yeah, J would be the row and I would be then the column. Yeah, so it would be basically it would be the row and I would be the column. Something like this. So now that we iterate, we would add this. I don't know if this word is just pseudo code, and that's how we get it. Okay, so let's start with the idea here. How do we do it? Then start focus. So we just do this, I guess, to be honest. And then this is our setup, and then we start. Total count per word. Let's get 1 second the Python cheat sheets. Here, let's put it maybe here. Oh, yes, and then continue without supporting us, sadly. Let's go for the lists. Strings list. List 1 to 3, list range. The 1, 11, list filter lambda, append, yeah. List, can I put like, list, I could just do like count 0. Basically that would be the first row. J equal row equal column. So that would be the first row. And then we just start for start iterating for loops for row in might be a little bit of more better thing. Loops for primes and primes for e value it enumerates. I think I like it more like this for e value in enumerate enumerate counts. So I will be the row. Maybe we just put it row. Row index maybe, and value index, value, no, value is value, and we start. So we do print. We just print. We just do this just to look what is there and we're doing correctly. And then we tested which with what applied it. Which you think with okay. So we do here a test with calculate. A bit long. Let's move probabilities with count small data document class small data is equal to this. And then alpha. Or we can just leave it empty. And let's see. And just print. Yeah, and we're printing all the rows. This is the first row, the second row, perfect. So we do, if it's not the first one, because we already have the first one, if row index bigger to 0, and we do a second one, which is basically call index value enumerate, and now we print, and then it should give us the value e value and remove the 0. Why is it complaining? There's something here. Name I, yeah, call index. Yeah, so this is correct. We're printing the column index. Why is because value is two things. Maybe we just do row, and here we do call. We're doing the same thing. Wait, in row, and yeah, perfect. Now we get really the values. Perfect. So now that we know what we're having, we just need to append it or put it to total count per words. Total count per words. And we go again to Python lists to see, can I do like, so some kind of sum or stuff like that. Read times 3, no, that's not what I want. Count, that's not what I want. Just want to use it equal to, but I think it was just me just do it the same way. We didn't have the time to think how it really works. Equals per word, the row index and the call index, total count per word, row index. Maybe we get it before, no? But it's the same. Now we just do the whole thing. Equals to total count index plus value. Perfect. This looks nice. And we simply at the end return total count per word. This is not yet what we need to return, but at least that's what we needed. Why is it complaining? Because it's outside of the definition. Yeah, here. Let's see. Valid index to scalar variable. Because total count per word is just call index. Sorry. Which call index is the word. And maybe we print counts first to make sure, because I'm not that sure. Print counts. Yeah, actually I think it is 1 2 3 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 20 1 2 3 4 5 6 7 8 9 10 11 12 13 14 16 17 18. Yeah, it's the same, so this is correct. This is the array for counts, which is a bit annoying that it's an array. Why isn't it a list? Remember, the guy told me that if I wanted a list, maybe I just do this. I'm also thinking maybe mutating the initial array, maybe do a copy, maybe this. No, this looks terrible. Looked better. How do I copy? Copy a list, Python. The copy method, yeah, we just use copy just to avoid mutating the initial list. Yeah, okay, perfect. So we got it. This is not really what we have to return, but we have the total count per word, which is nice. It's pretty. So now that we have it, what we need is basically, what we have is this. Now we have to sum from sum all of them basically. So maybe we do a small function here, like, oh, maybe we just leave it. Okay. We did it, basically. We got total count per word, which is nice. Now that we have total count per word, we need the sum of it. So it's basically iterating over it. And let's see if I remember how to iterate over a list. Loop lists, this lists, now while loop, x for x. List insert. I think I'll just iterate it in the normal way, in the Java way. So n sum, so we will call this denominator is equal to denominator is equal to, oh, 0 would be dangerous. Let's say it's equal to denominator equals to, yeah, let's do 0, but this is dangerous because then if we have nothing in total count per word, it will be a division per 0. So we go and say for now we can do the items in how was it? Loops here. Loops here for prime and primes for item in total count per word. So for each item we do denominator plus equals to maybe we don't call it item, but just like count times count times alpha. So we sum the value of the denominator by this, and then we just do it until we count them all, and then perfect. Now we have the denominator, and then result, which is basically the denominator and then denominator and numerator, and the numerator is equal to but like total count per word times alpha. This is hard word index. Because this is the sum of all of them, but what is this? NumPy matrix containing one row for each class. One row for each class C and one column for each word. I'm a bit confused. We have this. We have this. This is a sum which is actually easy to get. Maybe maybe you just ask AI, because now I'm a little bit. How would you use this? You use this in a function. Oh, it made it so easy. Word counts. I'm dumb. Yes. So this is good. The denominator is probably right. No, the denominator is not right. Where is it? Yeah, it's determining how often it appears, which is what we got. How often they appear. One column for, okay, just one column. And then we do this. Okay, I kind of got it. We just don't need this. This was more confusing. So there's one row and one column for each word. One row for each class C, which that's what column for each class C and sorted. But how many class C are there? Now we need to use document classes for sure. Documents. Oh, often the word operator of documents of class C, so we just count counts. Okay, today was not like the best stream.